Hello everyone. In this lecture, we'll discuss about the stress strain curve for mild steel. So before understanding the stress strain curve for mild steel, we need to familiar with some basic terms related to this topic. So what are the terms is nothing but the first one is stress and the next one is strain and also Hooke's law and elasticity and plasticity. So in the previous lecture already discussed these topics, but once again we'll discuss here. The stress is nothing but if the applied force cause changes in dimensions, means that material is said to be under some stress, and this is directly proportional to the force. And strain is nothing but here the change in length to original length means some dimensions will be changed due to the material is stressed, and Hooke's law is nothing but stress is directly proportional to strain, and elasticity means regain its original position after removing the external load, and plasticity is nothing but in this plasticity the permanent deformation will occur in that material. So these are the basic terms to remember the before going to start the stress strain curve for mild steel. Now let us start the stress strain curve for mild steel. So this mild steel, we know the different types of materials. In the different types of materials, we have three different types of materials. One is ductile material, brittle material and malleable material. So this mild steel is a ductile material. So this is a type of ductile material. So when a ductile material means like mild steel is subjected to some tensile force, we know the types of forces also. Tensile force, compressive force. Uh, in that the tensile is nothing but the force is acting away from the member. So here in this ductile material like mild steel, here I am choosing this mild steel material. For that mild steel, if the tensile force is applied on that material, it undergoes some stages. It undergoes some different stages before the failure point. So stress strain curve is the graphical representation. This stress strain curve is nothing but it is a graphical representation of these stages before failure of that material. So here different materials have the different curves, but usually the all the ductile materials have the follow the same similar pattern. So here the list of stages when ductile material is subjected to force. Now these are the stages. The first one is the proportionality limit, second one is the elastic limit, and third one is yield point, ultimate stress point and breaking point. First we'll discuss about this proportionality limit. So in this graph, the first point, this is the origin. In x-axis we are taking the strain value and in y-axis we are taking the stress value. Okay, stress versus strain here. For mild steel, we are applying some tensile force to that mild steel, and before failure of that material, these are the stages. In that the first stage is proportionality limit. So what is proportionality limit means? Here this is the in this figure here this A point is a proportionality limit. So here the stress and strain follow a relationship. We know that this that is Hooke's law. That relationship is known as Hooke's law. Up to the limit of proportionality, the stress is directly proportional to the strain. Means up to that point, the stress and strain remains constant. The stress and strain remains constant. So that point is called as proportionality limit, because up to that point the stress and strain are in remains constant. So that point is called as proportionality limit stress or limit of proportionality, this point A. And coming to the next stage is elastic limit. In this figure here, you can see this point B is a elastic limit point. Up to this point B, the material will regain its original shape, is unloaded. So this point is called as elastic limit. So up to B point, it is perfectly elastic from origin to B point. Here the material will return back to its original position if it is unloaded before the crossing the point B. That point is called as elastic point or elastic limit. Up to that point B, the material will regain its original shape. And coming to the third point, in the third point, this is yield stress point. In the yield stress point, here the stress after which the material which extension. So this C2D portion is the yield strength portion. That C point is nothing but upper yield point and D point is lower yield point. So point C is the yield point on the graph, and here at this point the stress is called as yield stress. Means here that yield point or yield stress is nothing but when a material is loaded beyond its elastic limit. Means at this portion here it will not regain its original shape. There will be some deformation. There will be always some deformation. That portion is called as yield strength portion or yield limit. At that point, we have some stress. That stress is called as yield stress. And coming to the next stage, that is ultimate strength. So this is the ultimate strength. In this figure, here the point E is a ultimate stress point. Means at this point, here the material have reaches the maximum strength before breaking, and this is also called as ultimate stress, and also it is corresponding to the peak point. It is the highest point. The peak point is nothing but highest point in this graph, stress strain graph. After this point E, within a minute, within very short time, the material will lose their strength. Means the material will fail. So this point is called as ultimate stress point or peak point. That point is capital E. And the next point is fracture point or breaking point or point of rupture. So if this F point, this is the F point. In this figure here, you can see this point F is the breaking point. Here this breaking point or breaking stress, at this portion, at this point, the material will loses their strength. Means it will be break. It will break. Here the stress associates with this point, that is breaking strength or rupture strength. Here the stress is corresponding to this point, that is called as breaking strength. So at this is the final point, the final stage of the stress strain curve. Here the material fails. So these are the stages of the stress strain curve. The first one is proportionality limit. Second point is elastic limit. Third point is yield limit. Fourth one is breaking before breaking, that is the maximum peak point. That point is called as ultimate, and the last one is breaking. So now here in this slide, here you can see this, the true curve versus apparent curve. So in actual we'll get one type of curve, but as per application we learned one type of curve. So this is the true curve. We'll get this type of curve, but we have studied this type of apparent curve. So at this portion, up to yield point there is no change. Up to upper yield point and lower yield point there is no change. The limit of proportionality is there and the elastic limit is same and yield point is also same. Coming to this, after upper yield point or after lower yield point, there are two different points. One is the ultimate strength and one is fracture. Those 2 points are different. This dashed line graph indicates this is the true curve and this is the apparent curve. We have studied about this apparent curve, but in practical we'll get like this. This is the true curve. So here also you can see up to point A, this is the continuous up to this limit of proportionality. At B point, up to that B point, this regain its personal shape. After that, the material will changes their stages based on applied load. When we reach the maximum load capacity, at that time the material will lose their strength. So this is the stress strain curve for mild steel. Thank you.